So I'm Winkelmann from Wolfson Microelectronics, actually the methodology guy for everything digital and mixed signal related, especially around verification. So first of all, I would like to tell you a bit about the products Wolfson does to set the challenges I present afterwards in a context. So Wolfson Microelectronics develops chips all centered around audio functionality pretty much. So you've got several audio input streams, be it from analog or digital microphones or any other digital input source, which are mixed together, effects applied, noise cancellation applied, and then output on speakers, earpieces, or some other digital output. So even these devices seem to be fairly different. The audio functionality is fairly similar between them. So that leads to a platform approach, actually, which we adopted at Wolfson. So you got a central platform which describes most of your design, and each derivative itself is only described then as a configuration file, pretty much. And that configuration file for each derivative contains the configuration for each IP as well. So from all this configuring, we then code-generate not just the RTL, we also code-generate the verification or make it configurable that way. We also code-generate the register map. And from all this generation and from all these not static IPs anymore, we actually have now very configurable IPs, and the tool vendors don't really support that. So at the moment, if you look at IPexec or some other standards, or even in the register map space, everything is considered to be static. So you've got a static IP, and you can't really shuffle around functionality or leave away certain registers. And we would like to see a bit more tool support for code-generated, highly configurable IP. And we also generate the SoC level, actually. So the entire thing is basically a template for a derivative. So that leads me to the first challenge, which is traceability. So with most of the requirements centered around the platform, we also are reusing requirements, not just the RTL verification files, we're actually using a lot more. We want to reuse a lot more. We want to reuse pretty much all other artifacts we can find solutions. So we want to trace the requirements, what is equal, what is different between the different derivatives, and in case you find a bug, you want to be able to see basically, if I find a bug in a certain IP, you want to trace that back to the actual platform release you have to use, and finally trace it back to the actual chip derivative you have taped out or currently making. So if we draw that line a bit further and branch off certain other platforms, quite complex, so over the next 5 years we will see that problem being increased. Great. The next challenge is actually scalability. We want to streamline the entire reuse process in a way that we can suck out as many derivatives as possible, so we can target the actual customer for the most cost-effective use. Scale the platform basically down or up, whatever it needs. And for that, reuse must happen, as I said before, over the entire range of artifacts we have. So, in addition to that, if you look at the chain platform, we want to be able to quickly tell basically what we can change in terms of the case RTL file. And that leads to the challenge that we need to trace and track actually which configurations of the key of the platform you have actually verified already. Or which configuration, if you create a new IP, you target first. Do you verify the entire configuration space? Probably not. It takes time. You just target the customer solution which you're interested in. Probably too little. So you need to find a balance there. The tools need to support basically that we cannot just verify the static IP, but also configurable IP, show us basically which configuration has been verified already.
And the third challenge is about mixed signal. So hence, Wolfson has always been a strong mixed signal company with analog ADC stacks and all sorts of stuff on the chip.
Mixed signal has become more advanced over the past few years, and there are quite a few modern digital techniques emerging on the market, which I quite like to see. So you got this variety of abstraction techniques now, beginning with real number modeling, or Verilog AMS, or VHDL AMS. Maybe you can even apply emulation once you have everything in the digital world. Then you got the added complexity of more power modes, which you want to apply to mixed signal verification as well. Also, this is a technique borrowed basically from digital space, which now needs to be applied in the mixed signal space. So upcoming System Verilog 2012, for example, includes features to model multi-value real net. So you can actually model the voltage, current, and any kind of meta information in an event-driven environment. So will that be supported on emulation platforms? I don't know yet. Also, UVM AMS allows us to adopt actually functional and metric-driven verification into the mixed signal space. So you add constrained random, you add cover groups and assertions, all with these real number models basically you have written in the first place, and plug that into an UVM AMS test bench. And all of a sudden, you've got quite a digital loaded test environment for your mixed signal chip. So to sum that up, the analog and digital engineers need to work closer and closer together in order to face these challenges and implement actually the modern technique. So the boundary is really fading, especially for mixed signal between analog and digital verification. So thanks for listening.